All right, so this is Unit 11. We are going to be talking about gases and the gas laws. So gases can be anything that is in the gaseous form. So anything from steam to vapor to propane, carbon dioxide, air, many different things that we're going to talk about. All right, so gases are everywhere. They're all around us, right? We use them to breathe. They're our atmosphere, which make the earth livable. But we also use them. We use them in things like neon lights. We do use them, unfortunately, as bioweapons. Hot air balloons use gas. We use them for pneumatics. So this is a linear actuator here. So we use gas to move different things. And we can also use them in things like staple guns, nail guns, things like that. All right. So, what is a gas? The definition of a gas is that a gas is matter that has no fixed volume or shape, and it uniformly fills its containers. So, you can see this one on the left. This here is a gas. So, the atoms in a gas are the farthest apart, they have the most energy. In a liquid, the atoms will be affected by gravity. So they'll be pulled down, although they will also kind of take the volume of the container on the bottom. And where a solid actually has some adhesion between the atoms, so we can fix those into some sort of shape. There we go. So I mentioned before that there is gas all around us, and that's in the form of air. So air is actually a mixture of several different gases. So the first one is nitrogen. So nitrogen, you see here, there's 78% of the air is nitrogen. So most of the air around us is nitrogen. 21% of the air around us is oxygen. So that's what we breathe. Argon, which is a noble gas, is about 1% of our air. And if you look, carbon dioxide here as a total percentage is just 0.03% of our air. So carbon dioxide is a very small percentage of our air, but as we'll see later, it affects the greenhouse effect on Earth a lot. So we'll be talking about that in more detail later. So most of our air is nitrogen. And if you guys remember, nitrogen has three triple bonds. The Lewis structure looks like this. And those three triple bonds make it very stable and hard. So that means it's inert. It doesn't react with very many things. And it's hard to pull the nitrogen apart. Gas, so as we increase our energy, going from a solid to a liquid to a gas, we increase the kinetic energy of our atoms, all right? So kinetic energy is just energy due to movement. So as we go from solid to liquid to gas, we get increasing kinetic energy. And this is how I want you to draw this on your notes. So as we go from solid to liquid to gas, we have more energy in our systems. So the atoms are actually moving more in a gas than compared to a liquid than compared to a solid. Kinetic molecular theory is a way of describing how gases are. It's a theory that all matter consists of particles that are in constant motion. So if you guys remember, zero motion, so no motion, is absolute zero. Absolute zero, right? Which is 0 degrees Kelvin, right? But everything on Earth is above that. So all the molecules or in this theory, it's assumed that all molecules have random motion, that there is a small volume of molecules compared to our total volume, and that there are small forces between the molecules. So this is only for a gas, right? Because we talked about liquids have intermolecular forces, and with a solid, we were going to have very large forces. So this is only for a gas. With gases, we have something called gas pressure. So pressure is due to the result of the gas particles actually hitting a container. So if you have a gas without any container, there won't be a pressure, right? The units we are going to be talking about are atmospheres. And if we have an empty space with no particles or pressures, that creates a vacuum, right? So that would be the absence of pressure because we don't have any molecules. Atmospheric pressure is due to the weight of our atmosphere. It's actually due to the weight of the air, and it will get higher as you go down lower. All right. So if you're up on top of a mountain, your atmospheric pressure will be less. If you're down in Death Valley, your atmospheric pressure will be higher. At sea level, Savannah, the atmospheric pressure is 1 atmosphere. A barometer is a device that actually measures pressure. There's two different barometers here. There's a mercury barometer here on the left. So this is a container that has mercury and some sort of scale in the middle. When the pressure increases and pushes down, it will push the liquid up and cause an increase in the reading on your scale. Another one is an aneroid barometer here on the right. This actually uses a spring. This uses a spring in the middle. And you might see these, sometimes people will have these in their house, like to measure the atmospheric pressure for high and low weather systems. So that is called an aneroid barometer. Now, a lot of times a pressure transducer is used. So a transducer is just something that converts the pressure to an electric signal. Okay, so what it happens is it has an open chamber here. So this is open to whatever we're measuring, right? And we'll have some pressure here on the middle. There's like a little drum, kind of. This is almost like a drum, or it's called a diaphragm actually, but and it actually, an increase in pressure will push on this and it will deflect that. And they use it's called a strain gauge. You guys don't need to know that. But anyways, a strain gauge can convert a mechanical change there to an electric signal. All right. So that's what it actually does. We have a change in pressure will actually cause a change in the electric signal going out. And you can calibrate it. So this is what they use in things like car tires, where you want to know the pressure digitally. All right, and that's the end there.